Hello, everybody. This is Dr. Balknight coming at you this morning. Just want to get the first lecture video out for your review and viewing pleasure. Once again, don't forget that your first current event is due tomorrow, Wednesday by midnight. All right. The example for that can be found underneath the course content, the course content tab. Okay, you go to the course content and then assignment directions and examples. And this is a little example of the current event right here, and then a little video showing you how to use the proper citation for that assignment. Okay. And I got a couple things to go over today. First, I want to talk about those assignments and how I want you to approach this class, and actually all of your education here at Robert Morris or whatever you're doing, which is using your critical thinking skills. Okay, when you're picking out these things for your current events, make sure that they're current and dealing with environmental science and all that other rigmarole. But ask yourself important things. All right, is what you're hearing is true? Is this making sense? And all this other stuff. So here's a little PowerPoint. This is underneath the PowerPoints for you. It's the steps to critical thinking. All right, and remember, critical thinking is not being a name, dismissive of things. All right, it's just simply asking the question: Am what I am hearing or reading is true? All right, and then you got to do other things to see whether or not it is true. Okay, that's what the critical thinking is all about. It's about asking that question: Is this really what's out there? All right, and then going through a process of thinking and figuring out and verifying that yes, this is an actual thing. Global warming, anthropogenic warming of the earth is a real thing. I mean, and that just comes down to the basics physics of physics. All right, carbon dioxide is a greenhouse gas. It's the way it is. So when you're going through your current events, I want you to use your critical thinking skills, and even in this class. All right, and one of my favorite things is Carl Sagan's baloney detector. All right, and this is really important too, especially with all this quote unquote fake news out there. You need to ask how reliable are your sources of this claim. Are they real people, real scientists making this a fact, or is it just a reporter? And is that reporter citing the scientists, or are they just making up a bunch of rigmarole without no citations and stuff like that? All right, so do your due diligence when you're doing these current events and make sure you're using credible sources. And like I said, I gave you three sources in that example. You don't have to use them. They're just good sources that have a lot of good renewable energy, and how we're going to get out of this fix. And there's more sustainability concentrated. Okay, yes, they do have a bias. All right, you got to know what position does the majority of, or where is this? Number six, what do you know about the source of funding and stuff like that? Who are these people that are writing these articles that you're going to review. All right, but I want you to have fun with that and do something that you like. All right, just try to keep it underneath a environmental science rubric. Okay, so let us get into the what the heck is that PowerPoint for this first um, chapter. All right. So, like I said, this is what your book looks like, the essential environment, the science behind the stories. You don't need any of the extra supplementals for that. Okay. And we're going to go over chapter one today. And we're going to talk about the field of environmental science, its importance, the importance of natural resources and ecosystems. We'll talk a little bit about population growth and resource consumption and stuff. And then we'll also get deeper into those subjects as we move on in this class. We'll talk about the ecological footprint for society and what that is. We'll talk about the scientific method, a little bit about the ethics, environmental ethics that surround this field, global environmental pressures, and then we'll talk about the concepts of sustainability and sustainability development, or sustainable development. And that is the rubric we will be using for this class. We're going to be using sustainability and sustainable development as our rubric of how, this is my personal opinion, and there's a lot of ways that to look at how we're going to design the future. But in my humble opinion, I think sustainable development is the way we should do that. And that is defined as meeting the needs of the present without compromising the needs of the future. And, we need to decide what is a need, right? We all need food and water, right? That's pretty easy. Okay. I don't think we all need tennis shoes, Nikes, or whatever. All right. I'll let the free markets decide about that. But there's certain things out there in the world that belong to all of us, the air and the water and things like that. That's what we're going to try to concentrate on here. Okay. And we can debate what a need is. All right. I happen to think that healthcare is a need. I mean, being born is a pre existing condition, in my humble opinion. All right. And some people might not think that's a need, and you should not do that. All right. We don't need health, a single payer. Um, so the quote for this chapter is, when we heal this earth, we heal ourselves. This was said by David Orr, and it might have been said by somebody else before him too. But this is one of my I love this quote, because that's what I figure we need to do. If we start actually concentrating on healing this earth of all the things that we have done throughout humanity and try to restore the ecosystem the way it was, I think we will heal ourselves as a society too. We will actually all these crimes and depression and all this other stuff, these social ills that we hear about all the time, will kind of magically go away, because when people's needs are actually met, they have a happier life, right? And when I talk about needs, like I said, if I look at the lower two of Maslow's hierarchy of needs, right? So if you look at the lower two, it's like food, water, and all that. And then the next one is like security. So we need to have in society, we need to feel secure that we're not going to get robbed and things like that, right? And there's, safety. Right, we're going to make sure that when we're at our job, we're going to be able to, work in safety and not, get killed and things like that. Right. So when we work on those lower levels, all right, magically we let the individual become who they want to be, because they're not worried about being hungry and thirsty and things like that. They can develop those higher levels of Maslow's hierarchy needs and become who they want to be. And you could be whoever you want to be. All right. You can be a conservative, you can be a liberal, you can be anybody you want to be. All right. Just make sure you base it on your critical thinking skills, and you come to a good conclusion that you can actually prove that, yes, this is my stance and that's why I stand behind this. All right. Environmental science is a great class, and it's like a master of a jack of all trades, master of none kind of science, because there's a lot of different things you can do with an environmental science. You can be an environmental scientist or a college professor like me, right? You can also be an environmental reporter. There's a group called the Young Turks, and they actually hired an environmental reporter for their news station. All right, so you can just be that. All right, the specialized jobs in forestry. You can go to WVU and you get a master's of forestry and sustainable forestry out there. All right, environmental engineer, of course. And you can be a climatologist, fish and game warden, marine biologist. There's a lot of different things you can do in environmental science. So it's really a jack of all trades, master of none, and it's in every single kind of field, I believe, out there. Okay. So our island, Earth, right? Earth is just one, like a rock in the middle of this big, huge, freaking universe. I mean, the universe is huge, right? And that's all we have, all right? And we need to be able to take care of it so we can live nice, healthy lives, right? So the environment consists of all living and non-living things out there. So all the rocks and oceans and clouds and ice caps, everything that's out there, okay, is considered the environment. And environmental science is the study of how that natural world actually works, right? And how the environment affects us and how we affect it. All right. So it's humans' interaction. So I would define it as a study of the environment and humanity's ecological niche inside of it. All right. And we'll learn what ecological niche is a little bit later in this class, but it's basically, what is our specialty in the environment? Why are we here on this earth? Are we here to take care of it and use some different things and all this other resources, right? So how are we in the environment? So we rely as a society on natural resources. We don't really produce anything. That's kind of like a misnomer. All right. All we really do is move matter around. Right. And that matter gives us all these natural resources of food and minerals and fossil fuels and trees. And yes, even human labor is considered a natural resource. Right. Uh, and those natural resources can be renewable. All right. Which they are renewable energy is defined as replenished over a short periods of time. All right, typically in one lifetime, so about 100 years per se. All right, and yes, people live 100 years. My grandpa, may he rest in peace, just passed away, and he was 102 years old. All right, so a tree and sunlight are also renewable energy. It's just that the sunlight comes back every 12 hours, and that tree may take 80 to 100 years to grow before we can turn it into a house again. All right. And then we also have our non renewable resources, natural resources, which were formed a lot slower. And they're basically our fossil fuels out there, our oil and our natural gas, all right? But also our minerals, our gold and our diamonds and stuff. We can't really get those back after we, deplete them, okay? We rely on ecosystem services as well. This is what I studied for my PhD, is trying to put a price or a dollar figure on some of these eco services out there. All right. So in addition to the goods provided and resources, the canes and the tennis shoes and all that stuff, the earth provides us ecosystem services such as water purification and cycling of nutrients, climate regulation, pollination of all the trees and flowers, and also getting rid of all our waste, all our poop and stuff like that. So there's a service that we need to have. Mother Nature has a balance, okay? And we'll learn about these different services throughout this class. Population growth also amplifies our impact on the environment. And you can see here is the population growth of the United States, or not the United States, of the world. All right. And you can see it was kind of fun. We had the agricultural revolution and it bumped up because we were able to, have more food and we kind of settled down. Right. But you can see here in the industrial revolution, we had an exponential J curve. Holy cow. Did society just grow up and just boom up to 7 billion people. Right. And this is basically because of our intellect. All right. We were able to start extracting fossil fuels and use them for energy. All right. We built these cities and started doing factories. People always had a job and some income, and that allowed them to, provide more food for us. Oh, we also had better medicine and sanitation that allowed us to not only live longer, my grandpa at 102 years old, but also the children, it's called infant mortality rate. Were able to live past 3 years old again, okay? Because before, in this area right over here, 1,500 years ago, women would have 7 babies, but only 2 of them would actually make it to infancy through infancy. All right, and that dramatically dropped. So we just shot right up. One of the things we'll talk about is what is the carrying capacity of this Earth? Are we at 7 billion people? Right? How many people can this Earth actually withstand with hold? All right, and one of the ways we allocate that or distinguish how we do that is through that's called the ecological footprint. All right, and this is the measure by and this is measured by the ecological. It's a cumulative area of land and water needed to provide resources and waste disposal for a typical person. All right, so we look at what's called the biocapacity of the earth, and we say, okay, I had a little bit of Wheaties for breakfast and some milk, and I got a sweater on with some wool and stuff like that. All those things that I use in my day, we figure out how much land or water mass that I needed to live my life the way I live it. Right? It's not a precise number. All right, and it changes per individual. Okay, but it just tells us how much acreage or how much productive biocapacity each individual or community uses. Right, and I won't open up this video here, but you can watch this. You should go put in ecological footprint in YouTube, all right, or go to this and you'll see there's a nice little video of the guy that actually came up with the ecological footprint. Well, he did. It was a collaboration, of course. Science works together. Um, and he explains it a little bit more in how he came up with it. You can also visit their website. We'll probably look at the website here. I think you see their website in one of the assignments. And the next assignment, you actually calculate your own ecological footprint, right? Because what happens here is humans are using renewable resources 68% faster than they can replenish themselves. So we're cutting down trees 68% faster than they can grow back. And that is not good. That is the story of the Lorax happening, okay? And when this happens, and it happens in all ecological, you know, uh, systems, it's called overshoot, right? And when overshoot happens, next thing that's going to happen is a crash. So when we look at the United States or the world in 1970, it was calculated that our ecological footprint was right at the world. We were using exactly one world, so we were chopping down enough trees for the trees to grow back at this point, right? And then after 1970, our ecological footprint got bigger and bigger and bigger. Our population got bigger and bigger as well, right? And all of a sudden, we are at overshoot. So today, we need about 1.6 Earths, right? So we're out of that biocapacity land. We're using more biocapacity, productive biocapacity space than the Earth can provide. And we need to have that Earth a little bit bigger, right? And we can't do that. That's impossible. So we are going to have to make some decisions, all right? I'm not saying we need to go back to the Flintstone days, okay, and ride around in those little cars pedaled by our feet. But there are some smart things we can do, and we'll learn about some of those things as we go throughout this class. So Earth's natural capital is stored in resources, ecosystems. It's like our little bank account. Okay. And that's how what I studied for my PhD is this little bank account and putting all this natural capital, all our gold and our diamonds and our oil and our sunlight and all that little things and try to come up with a monetary value for them so we can actually decide what we want to do in the future, which one makes the most sense. Okay. If you leave the principal intact and only spend the interest there the in a bank account, your bank you'll be able to live off the principal, right? And all that productive capacity, all that stuff in the bank stays there, right? But when you deplete that principal, the account will be drawn down until it's eventually exhausted. And that's what we're actually doing. What we want to try to do is make sure that our productivity, our renewable energies and things like that stay intact for the long haul. Currently, we are drawing down Earth's natural capital, a practice that is unsustainable. It just is what it is. Okay. Historians have inferred that the environmental degradation contributed to the collapse of the Greeks, the Romans, the Angkors, the Mayans, everybody. All right, this is something that's repeated. There's a good book called Collapse by Garrett Diamond, and he goes through all these different societies and shows how they, were once a great empire, went to nothing. All right. Today's society is globalized, meaning it's a similar collapse would affect the entire world. All right. So we're not just like the little Romans today, we're the whole world. If the United States goes down, the whole world is going to crumble because we are the biggest consumers out there. Okay. The release of the book Limits the Growth was a pivotal moment in discussing this issue. Okay, so Limits the Growth is a book that was put out 1969, I believe. And what it did is it calculated the ecological footprint and it showed that we were at that one world and we needed to do something. A lot of people poo pooed this. And we look at the statistics today and it shows that they were actually right on track. We might not have the famine and all the stuff that they kind of foreshadowed, but it doesn't mean that famine and stuff really isn't happening. We just got to look a little bit closer. Our current consumption and consumption growth rates are, totally unsustainable. So, nature of environmental science. So environmental science is an interdisciplinary field, right? Jack of all trades, master of none. All right. So we need to know a little bit of ecology So we need to know how the systems work together, a little bit of biology, how plants and animals reproduce, a little bit of chemistry to make sure that water is clean, right? A little bit of African American science, so we know that we're not warming the earth or cooling it down, right? A little bit of history. I know why civilizations collapse, right? A little bit of political science. How do we properly distribute things, these natural resources, so we can meet the needs of the present without compromising the needs of the future, right? And also ethics. How do we want to decide what is right and what is wrong, and what we should allow, all right? So that's one of the reasons I really love environmental science. Environmental science also involves scientific study of the environment and our interaction with it. So environmentalism is a social movement. It's different than environmental science. All right, it's a social movement. It's dedicated to protecting the natural world. So these are going to be your activists and your protesters and things like that. All right, they're trying to actively protect the world from undesirable changes. Well, environmental science is based on science, right? It's a scientific study, and that's what we're going to study in here. And of course, I'll put a little bit of my environmentalism in there, all right? But I'll try to tell you the difference between my science and my environmentalism. And if I'm not clear, don't be afraid to speak up, okay? So, science is defined as a systematic approach, uh, systematic process of learning about the world and testing and understanding about it. Okay, so science may also refer to the cumulative body of all the knowledge that we have out there. And we have what's called descriptive science, which involves researching organisms and materials and systems that are that are new and well not known, are not well known. All right, so descriptive science goes into doing a lot of research, and there's a hypothesis driven science which uses experiments to test hypotheses as part of the scientific method. Okay, so we can go through and just collect the data, or we can do a hypothesis driven science thing. And you can see the scientific method. If you have first, you have your observation. Then you come up with your questions of why I observed this. You form a hypothesis. Okay, an hypothesis gives you predictions, and you go into the testing, and then you get the results and review the results. If you rejected the hypothesis, which you're allowed to do, you have to go back and change that hypothesis again. All right, and then you go through that until you get to a firm result. All right, and once you get to that firm result, all right, you can do this in a couple of different ways. You can have what's called independent variables. When you come up with a scientific method, you have what's called an independent variable and dependent variables. So independent variables is a condition that changes and is to be tested. All right, so that is on the right side of the equation. X equals y and y equals mx plus b. So y is the independent variable. All right, x, m, and d would be the dependent variable. It is the resulting condition that depends on the independent variable. All right. Wait a minute, I just messed that up. I just did that totally different. All right, erase all that. So the dependent variable is on the left-hand side of the equation. The independent variable is on the right-hand side of the equation. So these stay basically constant and give you the answer to the dependent variable. All right. So y is dependent variable is dependent on the mx plus b part of the equation. Okay. Sorry about that. In the controlled experiments, all right, we have what's called a treatment part and a control part. All right, so we'll have a treatment part of the experiment receives the changes, and then a control does not. All right, you'll see this in a lot of medical experiments. They'll give you one drug, and then one will be the placebo part. Okay. Scientists record data and information from the studies. They use what's called quantitative data, which is expressed in numbers, all right, all your little charts and graphs that you have, all right. And then an experiment may disprove or fail to disprove the hypothesis, but it never proves it to be true. So we'll never have a total 100% fact. All right, there's going to be sometimes in the scientific theory, there's always a possibility that it can change, possibility that I'll be able to walk through that wall. If enough evidence accumulates to support the hypothesis, the scientists may eventually conclude that it's well supported. Okay? So it takes a while for something to actually become a scientific theory. It has to be proven time and time and time and time and time again before it become a scientific theory. In manipulative experiments, the researcher actively chooses to manipulate the independent variable. So they'll take the y, or one of the variables on the right hand side of the equation, and change it up or down and see how that affects the dependent variable of the equation. These are not always possible, though, such as in cases of for global climate change and things like that. We can't really change some of those things. Natural experiments compare how different variables are expressed in natural occurring but different contexts. So the independent variable varies naturally, and the scientists search for correlations or statistical associations between these variables. And this is what the climate scientists do. So they want to find out what the dependent variable is, the temperature, average temperature of the world. And they look at all these dependent variables. All right. So they look at CO2 in the atmosphere, they look at methane in the atmosphere, how many clouds are out there, how far away we are from the sun, where we are on the tilt of the axis, where we're at in the orbit around, for the seasonalities. Okay, all these little variables, and then they'll keep all the variables constant, but just change one of the independent variables and see how that affects, and then they come up with that correlation. So if carbon dioxide goes up by 1/10, the temperature is going to go up by 1/10. I don't know if that's true or not. All right, but you get the point. All right, and everything else is held constant. Okay, cloud cover gets a little bit more, then the temperature drops this much. Okay. To do this, we used a lot of graphs to help patterns and see trends in the data. And the following four graphs are visualized data collections. All right, so we got all the same. This is all about fertilizer being added to the pond. All right, so they would add a pond and they had more fertilizer, and all of a sudden they got the little J curve going up here, and then this was the control pond with none. All right, and we can see this in a line graph, or we can see this in a bar graph. Okay, we'll see all different graphs and charts in this class. We can scatter plot it if we wanted to, or we can actually put it into a little pie chart. All right. So scientific process continues beyond the scientific method. All right. So besides just doing that scientific method, we need to finish it up. All right. And especially on the test, when I ask you what the scientific method is, you got to remember it's not only done with just your experiment. The researcher needs, when the researcher's work is complete, it needs to be submitted to the journal. All right. And the journal's editors, do what's called a peer review of it and look through it and make sure that it meets the merits of publication. And then when it gets out there, it needs to be tried again. All right. Like I did a economic model for the pricing of what's called a community supported agricultural system. All right, it's a farm business, a type of farming business. All right, and I try to figure out how the farmer actually prices their share, what's called a share. Every week, the uh, shareholders would come in and pick up a basket of fruits and vegetables and stuff like that for like 26 weeks. And I went out and I tried to find out how the farmer actually prices that. All right. And it was a pretty good econometric model, it's called. Okay. And I was able to figure out about 75% of that price. It wasn't really good. It was about a 75% confidence level of that. All right. But I don't know if that model is actually any good until someone actually reads it and tries it themselves as well. Right. So just because I did it doesn't mean that it's actually right. I still need some others to put it into action and see if it becomes that becomes a theory. Someone needs to actually repeat it. Okay. And here you see the graph of this. All right. So you have this regular scientific method, but don't forget after that, you have to write your scientific paper. All right. And that has to stand up to peer review. If the paper is rejected, you got to go back and try to do all this stuff again. All right, and I had my paper rejected once, and it was tough. I had to go back and redo a whole bunch of stuff. But if it's accepted, it goes to publication, and then further research needs to verify that yes, this was actually okay. Just because it has a peer review, it still needs to be repeated. Okay, and that's how a lot of it's like its own little fraud built-in fraud detector, which I love. Right, because it has to go through that peer review, but also if those peers aren't right, the community at large will actually do that. And there's been maybe a couple scientific papers out there that were actually full of junk data, and people were like, "This can't be." And what they ended up doing is, went through the peer review, was published, and all that stuff. But finally, got out to the further research by the scientific community and found out that these peer reviewers were wrong as well. All right, in science, it's a built-in fraud detector. All right, built-in baloney detector. Okay. Scientific practice continues beyond the scientific method. So if a hypothesis survives repeated testing, it becomes that theory. And a theory is the widely accepted, all right, well-tested explanation of one of the more causes and effect. Okay, so this is not like a conspiracy theory where it's not proven. This is proven. A scientific theory is proven time and time and time again. And you too can do the same experiment and get the same results. That's what makes it, you know, a theory. All right. So evolution is proved time and time and time again. Cell theory, atomic theory, plate tectonics. All right. All these things, you too can go and do those experiments yourself and get the same results. Okay. You can do carbon dioxide into a little greenhouse gas and see how high the temperature goes up and go, okay, that the physics model of the change in temperature from carbon dioxide is correct. Okay. Periodically, science will undergo what shifts, which are one paradigm or a dominant view is replaced by others. All right. For example, Copernicus in the 16th century, European scientists believe Earth was at the center of the universe at that time, right? And then we had a paramount shift of accepting science. But and when I look through history, uh, a lot of the ancients knew that we weren't the center of the universe. Right? It was only during this time. So if we want to not being the center of the universe, to be in the center of the universe, to not be in the center of the universe again. But then we realized through science that we were the ancients were right. All right. Addressing environmental issues requires us not only to understand science, but also to use it to solve our problems, use our critical thinking skills, and go through the scientific process to see if what we're hearing is true. So, environmental ethics. So, ethics is the branch of philosophy that studies how people decide what is good, bad, right, and wrong. And you are allowed to have your own ethics to decide what is good, bad, and right and wrong. All right. And there's not one right way to live. And one of the great things I love about this America of ours is that we can have differing opinions. All right. But do not, I can't force my opinions on you. You can't force your opinion on you, but we got to stay within inside the law, right? So ethical standards are a criteria that help make this distinction. So there's categorical imperatives, which advise us to treat others as we would prefer to be treated ourselves. So that's the golden rule, right? Do unto others as you would have done unto yourself. So that is kind of a no brainer. I think there's not a religion or even the atheists. Everybody talks about this. I mean, it's a common ethical standard, right? The principle of utility holds that something is right when it produces the great practical benefit for the most people. All right. This is more of an economical thing that, we need to do the break even analysis. Does, paying school taxes or, doing some climate action and putting on a carbon tax actually benefit the most people, even though things are going to be a little bit more expensive? Okay. And that's what I studied in in my PhDs, is principle of utility, of trying to figure out if we save that mangrove, do we have a better? Does it have a greater practical benefit for the most people? All right, and sometimes that is a yes, and we'll talk about that later. So there's also what's called relativism, which believes that ethics are with social content. Well, universalities believe ethics inconsistent across cultures. So the universality of uh, treating others the way you should be treated um, is universal throughout societies. But relativism, some people say, you know, women can't do certain cultures say women can't do certain things, and who am I to say that they're not allowed? Right? You're a sovereign nation. You can do what you want. I might not believe that. All right? I think women should be just equal as us. All right? And I think they should actually have more power. But I am not uh, in charge of Saudi Arabia. Okay? And we need to know that ethics do vary from within social contents. Okay? Might not like them, but I have to accept that they're allowed to be who they want to be. I could try to persuade them to, do something else. Okay, but I can't force them. That's for sure. The application of ethical standards in relationship between humans and non-humans, entities, and environmental ethics. So, is the present generation obliged to conserve resources? Is that what we're supposed to do? Do we need to save all the fossil fuels so later generations can use it? Or do we just need to use it and to make something else so they can find a new economic substitute for all the oil that they're not going to have? Okay. Can we justify our communities from being more polluted? Are we allowed to pollute or should we not pollute? Okay. Um, and we'll talk about that later. We base it on what is generally considered safe principles. So here in the United States, we say if how much lead in your body you're allowed to, and just before you become impaired. Okay, and then that's what we let the factories put out. Okay, are humans justified in driving some species to extinction? Are we allowed to kill off something because it's dangerous to us, or something like that? Answer to these questions depend on your ethical standards and the breadth of the person's domain ethical concerns. So it's a broad topic. So there's no one right way to look at this. But we need, as a community and a society, to sit down and get all the stakeholders together and discuss these things. And we can do that. All right. As a society, and I've seen it be done before. Okay. So, in ethical standards, we have with anthropocentrism, biocentrism, and ecocentrism. So you can these three things are not mutually exclusive. All right, they kind of intertwine for each other. But anthropocentrism is the human-centered view. All right, biocentrism ascribes inherent value to both human and non-human life, and ecocentrism judges actions based on the effects of the ecology. And this is this is the most holistic perspective. Okay, and this is where kind of the realm I sit in. You're allowed to sit in any realm you want. All right, but it is a balance. And sometimes, I look at anthropocentrism. I want everybody to have that vaccine. I think it might be a good idea to get rid of COVID, right, and have that go extinct. Okay, and there's a lot of other bugs that I think I want to go extinct. All right, but they might have a purpose as well. Okay, but no one needs to be none of these are mutually exclusive. Okay, and I'll skip through these guys so we can get through this thing. But I ask you about these guys in the uh, homework assignment. All right, so you're gonna tell me a little bit about how to be a pole in that homework. So I'll skip over those things. But these guys were about environmental justice. All right, and it involves a fair and equitable treatment of people with respect to the environmental policies and practices regards to the income, race, and ethnicity. All right, because you'll see that if you do a broad view, if you look down on the earth and look at the different pockets of people, you'll see that the people with the less income and minority races and ethnicities are the ones mostly hurt by environmental problems. All right, they're the ones that are getting degraded. We've had to move out the Inuit Indians. I think the Inuit Indians from their island that they lived on for centuries because of global warming, and they had nothing to do with that. All right, they were not the problem, but their island is now disappearing. So you'll see that most of the poor people and ethnic minorities and all suffer from this environmental degradation. All right, living in the slums and the poorhouses behind the smokestacks of the coal-fired plants and stuff like that. And we need to decide if this is right, right, as a society. Okay, we have what's called cancer alleys here in the United States, where downwind from these factories, there'll be the minority companies, and they're have a lot more cancer rates in these little areas. So the way I look at the future and the way we should do our economics and build this next great uh, s- United States of ours is I think we should base it on what's called sustainability. Sustainability is the guiding principle of modern environmental science, and it's a constant you always encounter throughout this course. All right, because that just basically means living within the planet's means. All right, this planet will be around. It'll be about nothing lasts forever, but the sun's going to be around for about another billion years. And I would like to see humanity on this earth for those billion years. And that means we need to allocate our natural resources and not deplete them to the point where they become inexhaustible. All right. We don't have the story of the Lorax happen to us. All right. So we need to come up with those numbers of how many trees we're allowed to cut down so we can make sure we have enough trees to meet our needs in the future. It means conserving our resources so our descendants may use them later on, right? And maintaining fully functional ecological systems. So, meeting the needs of the present without compromising the needs of the future means making sure that these things, we were living in the planet's means, we're conserving their resources so they can use them later, and maintaining fully functional ecological systems so that they can have those natural capital that the earth provides. All right. So the environmental impact of humans has grown due to the combination of human population and excessive consumption of resources. And I happen to believe that it's more of an excessive consumption right now. We can actually live a real good life with the current 7 billion people we have on this earth, but there is no way. See, the United States, the average citizen in the United States uses about 8.6 hectares, and that is 16 acres, about there's about 1.2 acres to every 1 hectare, I believe. Okay, that's about 16 acres of biocapacity space compared to someone living in Haiti who only uses zero point 0.6 hectares. So we're using 8 more hectares than someone living in Haiti. And we're living a good life. And you can probably imagine the people in Haiti, they're a little bit, don't have the money to be able to spend, right? So the world average is 2.9, and the United States is 8.6. Okay. And you see the 20 wealthiest nations have over 55 times per capita income than the poorest. So it's really a money thing, all right, going on who can buy and purchase all those natural resources. Our reliance on fossil fuels is one of the best examples of how resource consumption amplifies human environmental impact. All right, so we look at all the fossil fuels that we consume, and it's allowed us to power all this machinery, industrial revolution, increase crop yields, run vehicles, all this different stuff. All right, and that is why we're consuming more and more and more stuff because it's a lot nice and easy. All right, it's been said that 1 gallon of gas or 1 barrel of oil is worth 50 years of labor, right? For of a like a blue collar worker, like a plumber or something like that. All right, the amount of energy that they use is the same over 50 years at their job is the same as 1 barrel of oil. All right, and just say over those 50 years, you're getting paid 50 grand a year or whatever. So that's like $1 million or whatever that number comes out. But a barrel of oil only costs us today, it's about $64. All right. So just imagine how cheap that energy is and how much that fossil fuel energy allows us to do. So we don't have to put that labor in our cars. Imagine walking all that way. All right. That's a lot of energy. Okay. So there are a lot of solutions to environmental problems that have arisen because of our consumption. All right, so we can institute a lot of different things. We're going to learn about these things throughout this class in the second part of the semester. All right, first part of the semester, we're going to learn about the basic concepts of environmental science and ecology, and then we're going to learn about renewable energy, how that can save us, and soil conservation, technology that we can implement. All right, talk about some laws that we can do, some policies. Okay, we are identifying endangered habitats and species that need to be protected, and these ecological services that they provide. All right, and we can also institute better waste management to help us conserve. So we'll talk about all these different solutions in the second part of the class. All right, and remember that this can be seen all over the world. So campus sustainabilities are all around. I'm kind of disappointed at Robert Morris. To be frank, that they don't have that big. They're not the recycling program is not as big as I would like it to be. But also, we got to remember that's because of the community. All right, they got to do that with waste management, and waste management doesn't offer this stuff, so it kind of fell apart. All right. But that doesn't mean that we can't put some native plants on the campus and things like that. All right. Do some organic gardening. I have a 40-acre farm. And someday my big dream is to farm it out and then sell my produce to Robert Morris so you guys can eat it. All right. All my fresh lettuce, all my almost deer tongue lettuce and Cherokee tomatoes and stuff like that. All right. But we can do those kind of things if we try hard enough. All right. We just got to get active. All right. But you never know what you can do. All right. Even professors can be activists. All right. So I went to the climate strike every year. I go down to the climate march. I didn't go this year though. I guess that hasn't happened. Maybe I will go this year. But I went last year, and here's me, my family, right? My sister and my kids, right? And I, right? And here's my son right there. And he got to talk to Bernie Sanders, baby. He was in there talking to Bernie Sanders. These are all young activists, 18 years old. Yeah, I don't know if you guys have ever heard of the XL pipeline and the protest that went on about 3 years ago where these Indians said, no, you're not going to put that through our land. These are these kids. I'm like, yeah, baby. All right. And then I got stuck on the elevator with Bernie. Yeah, Bernie's my man. All right. I'm a crazy Bernie freak. I couldn't believe it. And yeah, I'm in a wheelchair. Okay. But that's okay. I can still walk a little bit. I just got to use some canes. All right. So environmental science is a very exciting topic, all right? And it prepares you for the future. No matter if you're going to be an accountant or a nurse or a business individual or a engineer, environmental science is going to impact you. All right. With fewer than half the students in most schools taking any kind of environmental science course, many students are lacking environmental literacy. So hopefully in this class, you're going to increase your environmental literacy, and you got to understand why everything you do impacts something else. The butterfly effect is actually real out there. All right. So by taking this course, you will gain a better understanding of how the world works. All right. And you prepare the growth of green collar jobs, baby. Jobs, jobs, jobs out there. All right. And we've got a great opportunity to build a sustainable world. And you guys are the key. All right. So let's get busy on that. Okay. So that is the end of this presentation. I'm sorry it was a little bit long, but maybe I'll keep it shorter. So I'll probably put up the next chapter up here pretty soon for you, maybe tomorrow or maybe even later on today, because I'm kind of in the mood to talk about this kind of stuff. So if you guys have any questions, don't forget to, your current event is due on Wednesday, midnight. All right, go over the baloney detector and the critical thinking skills and make sure you got something about environmental science and enjoy. Do something you like. All right. So if you guys have any questions, just give me a shout out and I will try to get back to you as soon as possible. Okay. Thanks. Bye bye.